Here they are. For the minimax, it's a 3 examples on a diagram. They even work in a one-dimensional setting. You see, that's a perfect example. You see the domain is compact, it's bounded and closed, and you both have the max and the mean attained by the function. Max is here, mean is here. Here you see you ruin the on this diagram you ruin the continuity. You see the function has a drop, discontinuous this point of discontinuity at this point, and then the max value, or well, the supremum of that function. It's better say supremum because this value is no longer attainable, right? This limiting value, the highest limiting value, it's no longer there's no point for the function anymore to take that value exactly. So that's what you see if you drop the continuity. This is no longer true. If you drop the compactness, here's the interval. You see where you remove the endpoints, and by that you're ruining the compactness of the interval. If you remove the compactness from the assumptions, again you can come up with a counterexample. Here it is. This point, which before was the point of minimum, and it was part of the interval, but this point is no longer part of the interval. That's why again the minimum value this time is not attainable. That's the counterexamples for, I mean, that's just the demonstration of the two assumptions in the min-max theorem are important, continuity and compactness of the interval. That's a demonstration that the assumptions of intermediate value theorem are also, all of them are essential. You can't drop either of them. That's the classical setting, right? You have a function which is continuous on the compact and connected, path-connected subset. In that case, every point within this red interval is attainable. Every point is a value of some point, is a value of the function at some point. Here, on this diagram, you ruin path connectedness. You see, you remove the point from the interval. Now you take this as one single domain, these two separate subintervals. They are no longer path connected because you remove the point. And you see my function doesn't take all of the intermediate values. This interval, which is all covered by intermediate values, between some larger value, some lower value of the function, they are no longer attainable. And that's where on this function, on this group diagram, you ruin continuity. You ruin continuity, and again, intermediate value theorem is no longer true.